Good morning, students. In the previous class, we discussed about periods as well as groups in the modern periodic table. In briefly, in detailed manner, we discussed about the periods, even we discussed about the groups. But coming to the groups, we know we have 18 groups. Out of the 18 groups, I told you that the 2 groups will become under S block and the 6 groups will become under B block, and the remaining 10 groups will be included D block elements as well as F block. Okay, but in detail about the D block and F block means that the 10 groups we will discuss in D and F block elements lesson in detailed way. Now let us mainly discuss about the remaining 8 groups. Okay, out of the 8 in the previous class we already discussed up to 17th group. Now coming to the last group. What we call the last group? Last group is nothing but the 0 group. A normal numbering wise, this is known as 18th group. Okay? The last group of the periodic table means the extreme right hand side of the periodic table is known as 18th group. Now coming to the elements present in this 18th group. Now coming to the first element, helium, neon, argon, krypton, xenon as well as radon. Okay, so these are the elements present in 8th group, and we all know about this 8th group or 18th group. Generally it is known as, these are commonly called as noble gases. Okay, or these are also known as rare gases. So why they called as noble gases? Noble means we know precious. What about the Nobel Prize, right? Very precious, because here if you observe the availability of these elements, one common point, if you observe, all these are gases, so they don't present in the earth crust. Okay, so if they are, all these noble gases are present in the atmosphere, but if you observe the availability of these gases in the atmosphere, it is very less than this 1% at least. Okay, they will be present even lesser than 1%. Okay, so because of the less availability of these gases in the nature, these are known as noble gases, or also called as rare gases. They are rarely available. Okay, even because of their reactivity, these are also known as inert gases. Okay, these gases are also known as inert gases. Inert means they are not reactive. We know noble gases don't combine with other elements. Why they don't combine? Because we know that they already have octet configuration. Means they are already having 8 electrons in their valence shell. So because of the octet configuration, they are already stable. They don't want to lose electron, even they don't want to gain the electron. Okay, so because of that, all these elements are stable in the nature. That's why these are called as inert gases. Now coming to their physical study, we observe a common point we have seen. All these elements are gases. But coming to the last element, radon. Remember, radon is a radioactive element. Radon is a radioactive. Now coming to the common points what we are discussing, that is mainly the number of valence electrons. What is the group number? The group number is 18. When it is 18 or when it is more than 12, I told you to subtract 10. So from 18 if you subtract, it contains valency shell. Till 7th group you already written. So tell me the general electronic configuration of is 18th group. Okay? As they have 8 electrons, we all know that the electrons first enter into ns orbital, then they enter into np. So total 8 electrons are present in this line. Okay? So the general electronic configuration of noble gases or zero group elements is ns2 np6. Now if you observe all the elements, we can find one exception, that is helium. Because helium atomic number is 2, so it contains only 2 electrons. So it don't contain 8 electrons in the valence shell. It will have a doublet electronic configuration. Okay, so it contains the orbit which is completely filled. So because of that, helium is stable. Okay, all the remaining elements have octet configuration, but helium has doublet configuration. Okay. For example, if I ask you to write the electronic configuration of neon, neon belongs to which period? Because in all the groups we have did like the first electron of a group belongs to second period. But coming to noble gases, helium belongs to first period, neon belongs to second period. Okay? Because first period contains only hydrogen and helium. So coming to neon belongs to second period. So it contains 2 orbits. So the last orbit is second orbit. So principal quantum number 2. So its electronic configuration valence shell is 2s2 2p6. You tell me, for example, what will be the valence shell configuration of xenon? Once observe the position. Instead of thinking about its atomic number, I will give you, later I will give you a data using the magic numbers, how to find atomic numbers. But before that, if you know the elements in a group, first period, second, third, fourth, now xenon belongs to which period? It belongs to 5th period. So it belongs to 5th period means the principal quantum number, n value is 5. When n value is 5, its electronic configuration will be what? 5s2 5p6. If I ask you to find for krypton, belongs to 4th period, so 4s2 4p6. Argon, it belongs to 3rd period, so 3s2 3p6. Right? Now, I think there is no use of discussion about the oxidation state, because they don't involve in the formation of bonds. So they don't want to lose the electron and they don't want to gain the electron, because they are already stable. So that's why their common oxidation state is 0. Even the valency of these elements is 0. The valency of these zero group elements is 0. Okay? Valency means what? The combining capacity of the element is 0 for noble gases. But nowadays we know, out of that, both xenon and krypton forms compounds with a highly reactive non-metals like oxygen and fluorine. Okay? Out of this, krypton compounds are unstable, but some of the compounds of xenon are stable. So xenon mainly forms compounds with both fluorine and oxygen, which are highly reactive non-metals. Okay? But coming to the other noble gases, they don't form compounds, they don't react with the other elements. Okay? So this is the information we need to know about zero group as well as all the groups. Okay? So if we copy this, then we will discuss the next one. Now, coming to the next topic, in the 17s, IUPAC naming of elements with atomic number, elements with atomic number greater than 100. Okay? IUPAC naming of the elements with the atomic number greater than 100. So how to name the elements with the atomic number more than 100? So first of all, why do we need to know these rules and all? Because if you observe there, the starting 94 elements, all those starting elements are natural elements. Okay? So after 94 onwards are coming to this atomic number more than 100. All these are synthetic elements. Synthetic means man-made elements. Okay? So from the name you can understand that. So coming to these man-made elements, we have to follow some rules, at least from after 100 onwards. Means from 101 element onwards, we need to follow some rules which were given by IUPAC system. Okay? Because all these are man-made, so already those elements were named based on the name of the scientist. So borium, in the honor of the scientist Niels Bohr, it was named as a borium. Okay? Or coming to the Mendeleev, so in the name of Mendeleev, it is Mendelevium. Fermi, the scientist's name, in the honor of him, Fermium. Okay? So based on that technetium, like that, they are given different names. So at least after the 100 atomic number, those elements will be named according to the rules given by IUPAC system. Actually, the naming of these elements was given by CNIC, which was appointed by IUPAC. Okay? So where CNIC is nothing but Commission for Nomenclature, Commission for Nomenclature of Inorganic Compounds, for inorganic chemistry. So the rules for naming of the elements with the atomic number more than 100 was given by actually CNIC, but which was appointed by IUPAC. As every one of us know about this IUPAC. Okay? If not as a chemistry student or as a science student, 100% we should know about IUPAC. IUPAC means what? International Union of Pure and Applied Chemistry. International Union for Pure and Applied Chemistry. So this is the full form of IUPAC. Normally while naming the organic compounds, IUPAC nomenclature. Okay? So regarding the naming of the compounds, regarding all the related to chemistry, the rules, everything was given by the system known as IUPAC. Okay? So note down the full form. Then we will discuss about the rules, how to name the elements with the atomic number greater than 100. According to Ayurveda, while naming these elements, here their name was given based on their atomic number only. But while coming to the representation of the number, or while writing the name of that element, they given some root words. Here coming to the representation of 1, this number is named using a root word, that is an. Okay, the number 1 is represented as an. And coming to the symbol, representation for 1, the symbol is given as U. Okay, now coming to the number 2 is named as pi, can be represented with B, prime. 4, generally we know 4 here named as quad, so represented with the letter Q. 5 is named as pent, the letter P. 6 is named with hex, letter H. 7 is represented, is named as a sept, and the letter S. 8 named as knot, the letter O. It is represented, is named as N, and the letter E. Coming to 0, nil. Okay? N. Right? There won't be 10. Remember, this is 0. So 0 is named as nil and represented with the letter N. Okay. Now, using these symbols and these root words, so we are going to name the elements. Okay. Now coming to the name of these elements, if you observe there, they contain this some of these root words for the number, as well as along with that there will be a suffix. Suffix means, you know, at the end of the name we have. The suffix is IUM. For all the elements you will find suffix as IUM. Means at the end of the element, name of the, at the end of the name of the element, we should mention it as IUM. Okay, let us see. For example, let us go to the element 101. The atomic number of the element is 101. Coming to the name of this element, 1, nothing but its root word is 1. 0, nil. Again, un. The suffix is IUM. So finally, the name of the element is nil. Anium. Okay. The name of the element with the atomic number 101 is nil. Anium. Now coming to the representation, coming to the symbol which is allotted for that element, will also be based on these root letters. Root words. The starting letter, there will be 3 numbers, so starting letter of 3. But coming to assign the symbol, as we all know, any element is represented with the symbol with the starting letter as a capital letter. So, capital U. The next letters will be represented with the small letters U, N, U. Okay? Nil, Anium. Okay, so its atomic number is 101. For example, the atomic number 116. Okay, 116 means 1, again 6 means hex. The suffix is IUM. The name of the element is hexium. Okay, hexium. Dexium. Coming to the symbol, take the starting letters of the root words. The starting letter word, one is represented with U, again one. This should be written in small letters. H should be written in small letters because only the first letter is the capital letter. Okay. I hope you got an idea how to write the name. Now this time I am going to give a symbol for you, or I give a name first. You tell me the atomic number. The name of the element is was given as anil. Septium. Okay. The name of the element was given as anil septium. Now your task is assign the atomic number. Tell me the atomic number and assign the symbol also. If you observe there, anil septium. Okay. So an means how much? 1. Nil means 0. Sept represents how much? 7. So the atomic number of the element is 107. What is the symbol of the element? The symbol of the element, if you observe, U nil, N sept, S. So UNS is the symbol for atomic element with atomic number 107. Anil septium. Okay. Now second pen, another example. The symbol I given as UUO. What is the name of the element? Okay. The U is the symbol, nothing but it represents un. Again un. The 4 represents after. Plus suffix anyway we know as IUN. The name of the element will be what? Octium. Okay. The element name of the element is octium. So coming to the atomic number, means 1, again 1, octium. So 8. So name of the element is octium and the atomic number is 118. Okay. This is the way to write the nomenclature naming of elements with atomic number more than 100. Okay. So first we need to remember the names, root words given for the numbers. Once if you learn that, it will be very easy. Okay. Simply we are writing the root word of the 3 elements. Sorry, 3 letters, 3 numbers. At last we are adding the suffixes IUM. But coming to the alignment of the symbol, what we are following? The first letters of the root word. Okay? So let's go through this first properties. Now, after that, now coming to the one of the important topic, that is about the classification of elements in the periodic table. Okay, as I already told you, in that we have mainly 4 type of elements. That is S block elements, P block elements, D block elements, as well as F block elements. Before that, give the subheading as the division of elements or classification of elements. Classification elements in the periodic table. So first you need to write one point that the elements in the periodic table are mainly classified into four types. They are S block elements, S block elements, as well as P block elements, D block elements, and F block elements. What are these SPDF? We know the subshells. Okay, so based on that, these elements are categorized. Now, first let us discuss mainly about the first type, that is S block element. Okay. Before discussing about the properties of these elements, we need to know that what type of elements are generally called as S block elements. Okay. A S block element is nothing but the elements in which the differentiating electron enters into S orbital. Okay. So by listening the question, the definition, our first doubt is what is meant by that differentiating electron? Nothing but the last electron which is entered into the element is known as differentiating electron. Okay. So a S block element means the elements in which the differentiating are, in a simple words, the last electron, the elements in which the differentiating electron are the last electron enters into S orbital are known as S block elements. Okay? S block elements means the elements in which the last electron, what we call the last electron as differentiating electron, enters into S orbital. So such type of elements are known as S block elements. Now, how many elements will become under S block? Let us discuss. It is a simple task. A S orbital capacity is 2 electrons, right? S orbital can accommodate only 2 electrons. So the elements having the configuration like S1 as well as the elements with configuration S2. Okay? It may be 1s2, 2s2, 4s2, 4s1, anything. The elements which are having the electronic configuration in the valency shell as S1 and S2, all such elements will become under S block elements. Right? Understood the logic or not? Because in the definition wise, what we are saying, the elements into which the last electron enters into S orbital. Okay? So regarding S orbital, there are only 2 options. It can accommodate only 2 electrons. So if the last electron is present in S orbital, then it will be S block. 2 possibilities. The S orbital may contain either 1 electron or 2 electron. Both those cases will be, the elements will become under S block elements. I think even in the last class we discussed about the general electronic configuration of groups. To which group I given this type of general electronic configuration. Okay? Simple logic. Only one valence electron is present for first A group and two valence electrons are only present in second A group. So first A and second A group elements will become under S block elements, because in those two groups the last electron is entering into S orbital. Okay, so all the elements of first A group and the second A group are comes under S block elements. Okay. So note down the point first in the notes. Elements of first A and the second A group are S block elements. Okay, they are known as S block elements, because in these two groups the differentiating electron enters into S orbital. Okay. Now let us discuss about the main properties. The main properties of S block. Okay, the main properties of S block elements let us discuss. The first thing, if you observe the general electronic configuration, just now we discussed it. There are only two groups, or we know S block means the electron enters into S orbital. The S orbital can accommodate either one electron or two electrons. So the elements with the NS1 configuration or NS2 configuration will become under S block elements. So the general electronic configuration, if they ask, we can say NS1 to 2 or 1 or 2. Now, as individually we already discussed about the general properties of first A group as well as second A group in the last class. What is the common point regarding these two groups? Remember one point. All S block elements are, the common point of all this is, these are metals. Okay, all the S block elements are only metals. There are no non-metals, there are no metalloids. All S block elements are metals only. And as we already discussed, these are reactive metals. So when compared to P block elements and D block elements or F block elements, these S block elements are reactive metals because they are highly electropositive elements. They are highly electropositive in nature. Yesterday we discussed in a simple way what is meant by electropositive. Means they have more tendency to lose the electrons. As well, one more important point. They have very low ionization potentials. Okay? Means they will have very low IP values, ionization potential values. Means they require very less amount of energy to remove the electrons because they have more tendency to lose. Themselves they are ready to lose the electron. So it requires only very less amount of energy to remove the electron. Okay? So because of that nature, even these S block elements act as good reducing agents. block elements generally act as strong reducing agents, as well as these are all metals. So that is when these are good conductors of heat and electricity. Okay, they are good conductors of heat and electricity. And coming to their nature, as we all know, normal iron or other metals, if we see, they are very hard because they have very high melting and boiling points. But coming to these S-block metals, they have, first of all, they are soft metals. These S-block elements are soft metals. Generally, you know, metals are very hard. Iron rod, if you see, it will be very hard. But you may learn in the lower class that sodium is a soft metal which can be cut even with a knife also. Okay? So generally these metals are soft in nature because even they have low melting points and boiling points. Okay? These S-block metals will have, compared to the transition metals, they will have less melting points and boiling points. Okay? So these are the main properties of S-block elements. So mainly remember this one. Competitive examinations based on this general electronic configuration of different blocks, they are directly asking. Okay? As well as once go through these general properties also. Okay? About the remaining classification of these elements like P block, D block and F block, we will discuss in the next class. Okay? Thank you.